The Richmond Revolution. How Henry Kaiser's unconventional genius forged an industrial miracle and reshaped the modern world. On a crisp afternoon of November 12, 1942, in Richmond, California, a spectacle unfolded that defied centuries of maritime tradition and redefined the very limits of industrial production. There, poised at the edge of the launching ways of the Permanente Metals Corporation's Yard No. 2, sat the SS Robert E. Peary, a fully formed Liberty ship stretching 441 feet from stem to stern and displacing 490,000 pounds. This was not merely a new vessel ready for sea. It was a physical manifesto of a new industrial doctrine. Its journey from a bare keel to this moment of launch had been consummated in an almost inconceivable span of time, a mere 4 days, 15 hours, and 29 minutes. This single fact stood as a stark repudiation of shipbuilding conventions that had held sway since the era of wooden sailing ships and the American Revolution, where master shipwrights and their seasoned crews would typically devote 6 to 8 months of painstaking labor to construct a vessel of comparable size. As the final preparations for the launch commenced, the workforce responsible for this marvel stepped back from the massive hull. They were not the grizzled, lifelong maritime craftsmen one would expect at such an event. Instead, they were a cross-section of an America mobilized for war. Former secretaries, farmers, housewives, and day laborers who, just weeks earlier, had been taught the specific skills of welding and steel assembly. They stood as living proof that complex industrial prowess could be rapidly cultivated, not just inherited. The atmosphere was electric with a mixture of awe and disbelief among the gathered crowd of government officials, journalists, and rival shipyard owners. They had come to witness what many had dismissed as a publicity stunt, but they would leave as witnesses to a profound and irreversible transformation in the philosophy of manufacturing, a systematic revolution born of American necessity and innovation, the echoes of which would resonate for decades to come. The mathematics that would ultimately secure an Allied victory were being calculated not only in the war rooms of London and Washington, but also in the production statistics emerging from places like Richmond. These numbers were shattering every foundational assumption maritime experts held about the physical and temporal limits of ship construction, revealing a new landscape of industrial possibility. The Outsider's Gambit, a foundation of concrete, not tradition. This revolutionary journey had its origins on December 27, 1940, when industrialist Henry J. Kaiser, a man of formidable reputation but no maritime experience, put his signature on his first shipbuilding contract. Kaiser was a figure entirely alien to the insular world of naval architecture and shipyards. His career had been spent moving mountains of earth and pouring immense volumes of concrete for some of the most ambitious civil engineering projects of the era, including the Hoover, Grand Coulee, and Bonneville dams. He was a master of large-scale, rapid construction, but he had never before built a ship, managed a shipyard, or navigated the complex traditions of maritime engineering. Yet it was this 58-year-old construction magnate who boldly promised the United States Maritime Commission he would deliver 30 ocean-going cargo vessels for the besieged British government within a mere 2 years. The established shipbuilding community, steeped in generations of practice, dismissed him as a naive and opportunistic amateur. Their skepticism was so profound that the Todd Bath Iron Works, one of America's most venerable and traditional shipyards, only agreed to a partnership with Kaiser's organization under the assumption that their deep-seated expertise would be essential to compensate for his profound ignorance of the field. What none of his detractors could grasp at the time was that Kaiser's lack of shipbuilding experience would paradoxically become his most powerful asset. Unburdened by the "this is how it has always been done" dogma, he viewed the challenge not as a sacred craft, but as a logistical and manufacturing problem to be solved with ruthless efficiency. Among the many skeptical observers in those early days was William Francis Gibbs, arguably America's preeminent naval architect. His firm, Gibbs and Cox, had been entrusted with refining the British-designed emergency cargo vessel into the standardized Liberty ship plans. Gibbs had personally designed more ships than Kaiser had likely ever set foot upon. He represented the pinnacle of traditional maritime engineering, a world where every detail was meticulously drafted and every procedure followed established practice. The chasm between Gibbs' methodical, tradition-bound world and Kaiser's disruptive, production-oriented mindset could not have been wider. The assembly line doctrine, a clash of industrial philosophies, Kaiser's revolution began not on the waterfront, but in the planning offices. In early 1941, as Kaiser and his team of engineers, led by his brilliant chief engineer, Clay Bedford, examined the conventional shipbuilding process, they immediately identified its fundamental flaw for wartime exigency. It was inherently sequential and slow. The process mirrored that of a medieval cathedral builder, where the keel was laid and the vessel was painstakingly built upward and outward, with each task dependent on the completion of the last. A pivotal moment of inspiration came when Bedford visited a Ford Motor Company assembly plant in Detroit. He watched in fascination as automobile chassis moved steadily down a production line, with workers at each station performing specific, repetitive tasks, adding pre-manufactured components to the growing vehicle. The concept of a moving assembly line for something as large and complex as a ship was impractical, but the principle of bringing prefabricated sub-assemblies to a stationary hull for rapid final assembly was a revelation. Bedford returned to California convinced that ships could and must be assembled like automobiles, not built like traditional vessels. When Kaiser's team proposed this radical departure, the traditional shipbuilders within the Todd partnership considered the analogy absurd and dangerous. The first major shockwave came with Kaiser's proposal to abandon riveting almost entirely. For millennia, ship construction had relied on rivets, red-hot metal pins hammered through overlapping steel plates by coordinated teams of heaters, holders, and buckers. It was a slow, labor-intensive, and noisy process. A highly skilled crew was fortunate to set 100 rivets in a day, and a single Liberty ship required approximately 1 million of them, if built conventionally. Kaiser proposed replacing this ancient technique with electric arc welding, a method he and his teams had mastered while constructing pipelines across the vast expanses of the American West. Welding was faster, required less skilled labor per operation, and created a smoother, lighter hull. The maritime establishment recoiled in horror. Vice Admiral Emory S. Land, the chairman of the United States Maritime Commission, reviewed Kaiser's proposal with profound skepticism. His private correspondence, preserved in the National Archives, reveals the depth of this institutional doubt. Welding has never been proven reliable for hull construction at this scale. The British Navy forbids welding on warship hulls. Kaiser is proposing we bet America's supply lines on an unproven technology. Yet Admiral Land was also a pragmatist, staring into the abyss of the Battle of the Atlantic. German U-boats, operating in deadly wolf packs, were sinking Allied merchant ships faster than the combined traditional shipyards of Britain and America could replace them. In 1941 alone, over 3.6 million tons of Allied shipping would be sent to the bottom. Britain's survival was hanging in the balance, dependent on the lifeline of cargo crossing the Atlantic. American shipyards, using conventional methods, were averaging 230 days to complete a single cargo ship. At that pace, defeat in the Atlantic was a mathematical certainty. The Commission's decision to approve Kaiser's contract, therefore, was born not of confidence, but of sheer desperate necessity. Building the machine that builds the ships, the Richmond yard. Rises with contract in hand, Kaiser's organization moved with a speed that mirrored his eventual production goals. The Richmond shipyard site was little more than empty mud flats on San Francisco Bay in January of 1941. Using the same crews and methodologies that had built his massive dams, Kaiser erected a facility that was itself a radical departure from maritime norms. It horrified traditional naval engineers. Instead of the familiar longitudinal building ways and massive graving docks, the Richmond yard was laid out with the logic of a gigantic, open-air assembly plant. The facility was designed around 7 parallel building ways, surrounded by vast, open prefabrication areas. An extensive network of railroad tracks crisscrossed the site, designed to deliver massive steel subassemblies weighing up to 150 tons. A forest of overhead cranes, with capacities that seemed ludicrously excessive to traditional builders, was installed every 100 feet, capable of lifting entire sections of a ship, a complete bow, a multi-deck superstructure, an engine room unit, and placing them with precision onto the building ways. John G. Jack Riley, the chief naval architect for the Bethlehem Steel Corporation and a 30-year veteran of shipbuilding, visited the Richmond Yard in May 1941. His confidential inspection report, later declassified, blended sharp technical criticism with a tone of grudging admiration. Kaiser has violated every principle of efficient shipyard layout I learned in 3 decades of experience. His prefabrication areas are too large. His crane capacity is absurdly excessive. His building ways are too short. Yet I must admit the facility is designed for exactly what he claims: the rapid assembly of prefabricated sections. The human engine, democratizing skill and unleashing potential. The recruitment and training of the workforce constituted the next, and perhaps most socially transformative, phase of the revolution. Traditional shipyards drew their labor from established maritime communities, ports like Newport News, Philadelphia, and Bath, where complex skills were passed down from father to son over generations. Kaiser threw this model out the window. He launched a national advertising campaign offering wages 20% above standard industrial rates and, most importantly, a promise: "We will train anyone willing to work." The response was a flood of humanity. The first waves of workers arrived in Richmond in August 1941, men and women from America's farms, small towns, and cities, with no industrial background whatsoever. Kaiser's innovation was to deconstruct the complex craft of shipbuilding into a series of simple, repetitive tasks, directly borrowing from the principles of assembly line manufacturing. This approach proved devastatingly effective. By October 1941, Kaiser employed over 10,000 workers at Richmond, fewer than 200 of whom had any prior shipbuilding experience. The training was breathtakingly accelerated. A traditional welder's apprenticeship lasted 4 years, imparting a comprehensive understanding of the craft in all its variations. Kaiser's training schools, by contrast, focused on teaching a single, specific skill for a specific task. A worker didn't need to know how to weld in every possible position and material. They only needed to master, for example, the vertical seam on a bulkhead or the horizontal joint on a deck plate, which they would then perform hundreds of times. This specialized training took approximately 2 weeks, not 4 years. The same principle applied to fitters, burners, and crane operators. It was the democratization of skill on an unprecedented scale. As this new workforce gained experience through late 1941 and into 1942, the results began to speak for themselves in the most powerful language possible: plummeting construction times. Kaiser's very first Liberty ship had taken 197 days to complete, a respectable time, but not yet revolutionary. The second ship required 169 days. The fifth was launched in 128 days. By the 10th vessel, the time had fallen to 97 days. By the spring of 1942, the Richmond yard was consistently delivering Liberty ships in an average of 70 days, a pace that began to match and then surpass the output of traditional yards with their highly skilled, experienced crews. The power of the prefabrication approach, once dismissed by the old guard, was now undeniable. Instead of building a ship sequentially from the keel up, Kaiser's yards fabricated entire sections simultaneously in different parts of the facility. While one team was assembling a complete bow section in a prefabrication area, complete with its anchor gear and crew quarters, another team was building the stern section with its steering gear and propeller shaft installed. Elsewhere, other crews constructed the 4 massive cargo holds, the deckhouse, and the engine room as separate modules. Meanwhile, the ship's massive triple-expansion steam engine was being assembled and tested on its own foundation in a separate workshop. Then, in a carefully choreographed ballet of heavy lifting, the colossal cranes would move these multi-ton sections to the building way, where welding crews would join them together in a matter of hours. Albert Wooding, the production supervisor at Richmond Yard No. 2, eloquently captured this efficiency in a 1943 interview with Fortune magazine. In traditional shipbuilding, you cannot install the engine until the engine room is built. You cannot build the engine room until the hull is complete. Everything happens in sequence, creating a perpetual bottleneck. Kaiser's approach allows for parallel production on an enormous scale. While one crew is welding hull plates, another crew is assembling the complete engine in a separate, accessible area. When both are ready, we use a crane to lower the completed engine into the completed engine room module and weld it into place. Tasks that previously required weeks of cramped, difficult work now take a single shift. The statistics of this parallel production revealed manufacturing efficiencies that seemed to defy physics to traditional builders. A conventional yard might have 50 workers struggling for 3 weeks to install an engine inside the confined, partially built hull of a ship. Kaiser's system would assign 200 workers to assemble the entire engine and its supporting foundation in an open workshop over 5 days, then use a massive crane to position the complete, ready-to-run assembly into the hull in a single 8-hour operation. The culture of adequate results over tradition. Perhaps even more disturbing to the maritime authorities than the speed was Kaiser's conscious abandonment of centuries-old practices rooted in the pursuit of perfection. Ships had always been built from exquisitely detailed plans that specified every dimension, every bracket, and every fitting. Kaiser operated with simplified, functional drawings that provided basic dimensions and left many of the finer details to the judgment and ingenuity of the workers on the shop floor. To traditionalists, this was sheer recklessness. To Kaiser, it was essential flexibility. Vice Admiral Howard L. Vickery, the vice chairman of the Maritime Commission and a career naval officer, initially fought bitterly against Kaiser's push for simplified specifications. The minutes from the Commission's meetings document his remarkable transformation from a staunch skeptic to a reluctant, then enthusiastic, supporter, a conversion driven solely by the undeniable power of results. In January 1942, Vickery is recorded as stating, "I opposed Kaiser's request to reduce drawing specifications. Ships are not automobiles. Maritime construction requires precision." But by March 1942, he was forced to concede. Kaiser's yards were outproducing our traditional contractors by 40%. By June, the gap had widened to 70%. I learned that perfection is the enemy of sufficient. Kaiser's ships were not beautiful. They were adequate, and adequate ships delivered more cargo to our allies than perfect ships still under construction. As construction speeds accelerated through the spring and summer of 1942, a fierce but productive internal competition developed among Kaiser's own shipyards, which had expanded to 7 facilities across California, Oregon, and Washington. His son, Edgar Kaiser, a driven and capable executive in his own right, managed the Oregon Shipbuilding Corporation in Portland, while Clay Bedford oversaw the Richmond complex in California. The two men, embodying the competitive spirit Kaiser fostered, began an informal race to set new speed records. This contest became a public sensation, with newspapers tracking their progress like sports scores. Records tumbled until the Oregon Shipbuilding Yard launched the SS Joseph N. Teal in just 10 days in September 1942. While Vice Admiral Vickery eventually ordered these stunt demonstrations to cease, fearing they would compromise quality and distract from sustained production, the psychological impact was profound. Workers across all Kaiser yards now operated with the unshakable belief that extraordinary speed was not just possible, but was the new standard. The ultimate demonstration. The Robert E. Peary and the shattering of all records. It was in this atmosphere of heightened possibility that the ultimate demonstration was conceived. During a visit to Richmond in late October 1942, Vice Admiral Land made an offhand remark to journalists, which was overheard by Clay Bedford. The Admiral acknowledged the remarkable progress, but noted that even the recent speed records paled in comparison to what true mass production had achieved in the automobile and aviation industries. Bedford took this as a personal and institutional challenge. He proposed to Admiral Land that Richmond's Yard No. 2 would attempt to build a complete Liberty ship from keel laying to launch in under 10 days, effectively cutting the record of the Joseph N. Teal in half. Land, deeply skeptical but intrigued, authorized the attempt on the condition that it would not disrupt the yard's regular vital production schedule. Bedford selected the 47th hull to be built at the yard for this audacious endeavor. The ship would be named the SS Robert E. Peary, after the famed Arctic explorer, a fitting namesake for a vessel intended to conquer a different kind of frontier. The record attempt began at 1 minute past midnight on Sunday, November 8, 1942. It represented the prefabrication strategy pushed to its absolute logical extreme. Every single major component of the ship had been pre-built, inspected, and strategically staged before the first section of the keel ever touched the building way. The bow was a single, massive, fully welded unit, already equipped with its anchors, windlasses, and chain lockers. The stern section contained the fully assembled steering gear, propeller shaft tubing, and accommodations. The 4 cavernous cargo holds stood as complete, box-like structures. Most impressively, the ship's 140-ton triple-expansion steam engine, manufactured and test-run by the Joshua Hendy Iron Works in Sunnyvale, had been pre-mounted onto its own foundation structure, a self-contained unit ready for placement. What followed was less a shipbuilding process and more a meticulously timed assembly operation. The workforce of over 1,000, organized in perfectly synchronized shifts, worked around the clock. Cranes danced across the yard, lifting these colossal sub-assemblies, some weighing as much as 150 tons, and setting them into place with breathtaking speed. Welding crews, working in teams, immediately descended upon the joints, their arcs flaring through day and night as they fused the great sections into a single, seaworthy hull. Just 4 days into the effort, the ship was structurally complete. Hull sealed, engine installed, deckhouses positioned, holds secured. At 3:30 p.m. on Thursday, November 12th, a mere 4 days, 15 hours, and 29 minutes after the keel was laid, the SS Robert E. Peary slid down the greased ways into the waters of San Francisco Bay, fully formed and operational. It was delivered to the Maritime Commission for active service just days later, on November 15th, setting a second, equally stunning record of 7 days, 14 hours, and 32 minutes from keel laying to full delivery. The crowd of observers, which included the most hardened maritime officials and skeptical competitors, witnessed an event that forced a fundamental cognitive shift. Many had arrived expecting to see a compromised, incomplete shell of a vessel. What they saw instead was a fully equipped, functional cargo ship that required only minor fitting out before loading its first cargo. Vice Admiral Land, present for the launching, made brief remarks that were captured by newsreel cameras and which signified the capitulation of the old guard to the new reality. 6 months ago, I would have called this impossible. Traditional shipbuilding wisdom, accumulated over 3,000 years, said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The United States Maritime Commission will now require all contracted shipyards to adopt these methods. The ripple effect, transforming an industry and a nation. The psychological impact on the established shipbuilding industry was immediate and profound. The very yards that had dismissed Kaiser as an ignorant outsider just 18 months earlier now dispatched their top engineers to Richmond as students, not critics. The president of the New York Shipbuilding Corporation, one of America's oldest and most prestigious maritime firms, visited in December 1942. His confidential report to his board of directors revealed a complete ideological surrender. Kaiser has achieved what our industry considered impossible by refusing to accept our limitations. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise. The result is ships built in 1/10 the time at 2/3 the cost. We must either adopt his approaches or accept irrelevance. By early 1943, the Kaiser method had become the American standard. 18 shipyards across the United States were now building Liberty ships using prefabrication and electric arc welding. The average construction time for a Liberty ship plummeted from the initial 230 days to just 42 days by mid-1943. The United States was launching 3 Liberty ships every single day, creating a tonnage of new shipping that simply overwhelmed the sinking capacity of the German U-boat fleet. The Battle of the Atlantic had been won as decisively in the shipyards of America as it had been on the stormy seas by the navies. The social impact was equally revolutionary. The Kaiser yards became powerful engines of social and economic change. At its peak in 1944, Kaiser's 7 shipyards employed approximately 196,000 workers. In a dramatic break from the past, over 40,000 of these workers were women, comprising a remarkable 27% of the production workforce at the Richmond yards alone. Rosie the Riveter was, in many cases, Wendy the Welder. African-American workers, who had been largely excluded from skilled industrial trades, found employment in the Kaiser yards in the tens of thousands, working as welders, fitters, crane operators, and even in low-level supervisory roles, a level of workplace integration that was virtually unheard of in 1940s America. This democratization of skilled labor carried implications that stretched far beyond the war. By proving that complex, critical manufacturing could be performed by a rapidly trained workforce drawn from every segment of society, Kaiser's shipyards challenged the very foundations of industrial organization and labor relations. They demonstrated that human potential was a vastly underutilized resource, and that given proper training and organization, ordinary people were capable of extraordinary achievements. Enduring legacy, from wartime emergency to peacetime foundation. The legacy of Kaiser's Liberty ship program extends far beyond the war itself. While traditional analysts predicted a catastrophic collapse of the shipbuilding industry after 1945, the knowledge and techniques developed did not vanish. The principles of prefabrication, welding, and parallel assembly became the bedrock of global shipbuilding. When nations like Japan and South Korea rose from the ashes of war to dominate world shipbuilding in the 1950s and 1960s, they studied and implemented the methodologies pioneered at Richmond. The massive, hyper-efficient shipyards in Ulsan, South Korea, and Nagasaki, Japan, are the direct descendants of Kaiser's revolutionary practices. The statistics of the program remain staggering. Between 1941 and 1945, American yards built 2,110 Liberty ships. Kaiser's 7 yards alone produced 1,490 of them, 27% of the total. Construction efficiency improved so dramatically that the worker hours required per ship fell from 1.1 million for the first vessels to just 486,000 by 1943, with the most efficient yards achieving builds in as few as 350,000 worker hours. The ships themselves, designed for a 5-year service life, proved remarkably durable. Many sailed for decades after the war in commercial service around the globe. Several survive today as museum ships, a testament to their robust construction. The SS John W. Brown and the SS Jeremiah O'Brien are still operational, with the latter sailing to Normandy under its own power for the 50th anniversary of D-Day in 1994. 52 years after its construction, unexpected legacies also emerged. To provide healthcare for his massive workforce, Kaiser, in partnership with Dr. Sidney Garfield, created a prepaid health plan that evolved into Kaiser Permanente, one of the nation's largest and most influential health maintenance organizations. The Fontana Steel Mill in California was built by Kaiser to supply his yards, permanently altering the West Coast's industrial landscape. The boomtowns like Richmond and Vanport City, while temporary, demonstrated the transformative power of concentrated industrial investment. In conclusion, the story of Henry Kaiser and the Liberty ships is more than a tale of wartime production. It is a timeless lesson in innovation, leadership, and the power of challenging convention. Kaiser's greatest achievement was not the 1,490 ships his yards produced, but the fundamental transformation in industrial mindset he catalyzed. He proved that the greatest limitations are often those we impose upon ourselves through tradition and conventional wisdom. The SS Robert E. Peary, built in less than 5 days, stands as an eternal monument to a simple, powerful truth: that human ingenuity, when unshackled from the past and empowered by a clear goal, is capable of accomplishing the seemingly impossible. This legacy, carved not in steel but in the transformed understanding of human potential, continues to inspire and inform modern manufacturing, management, and the relentless pursuit of progress.